Okay, so this presentation is on finding the formulas for counting permutations and combinations. And this is continuing a series of short little talks about counting. So you would need to have already seen the video about the relationship between these two formulas. We found out that nPr is the same as nCr times r factorial. So we'll use that in a few minutes. Okay, but picking up from there, we're going to work out the formula for 5p3. So that's how many permutations of size 3 could be selected from a set of size 5. Now here's a set of 5 colors. And a permutation of size 3, it's an ordered, non-repeating collection of 3 elements. So I can take any 3 colors from my set of 5 and I write them in a particular order, and that makes a permutation. So these 2 that I've drawn here are 2 different permutations, same colors, but in a different order. For the sets, we write the squiggly brace characters to mark the beginning and end of the list. And for the permutations, where the order matters, we use the curved parentheses just so you can tell the difference when you write it down. So we're going to find 5p3, and then we'll generalize to make a formula that we can use for all problems of this type. Now to find 5p3, it's pretty easy. There's 5 different choices for my first color. But then once I've chosen my first color, now there's 4 different ways that I can go for the second color. So we're already up to 4 ways if I start with a green, or a different 4 choices if I started with the brown. Whichever one of the 5 colors I start with, there's 4 ways to follow up and make the second color in order. And so there's 5 times 4, or 20 ways to get just the first 2 colors. Well, once I know that my first 2 colors are, say, red and blue, now there's 3 choices left for what's going to be the third color. So for each one of these 20 pairs, these 20 first 2 colors, there's 3 ways to finish it off. So I have 20 ways to start, and for each way, there's 3 ways to finish. So 20 times 3, we're up to 60. And so there's 60 ways to make a permutation of size 3 from a set of 5 elements. Order matters, repetition is not allowed. The number's going down because of not allowing repetition. You can't get the same color twice. Now we want to generalize from this to make a formula that's going to work for any, not just 5 and 3, but any n and r, where n is greater than or equal to r. These are whole numbers. Okay. So, what I want to do I mean, I'm finished already with the 5 times 4 times 3, but I want to make a formula that I can write down. And, well, if I wanted to, and I do, I could multiply on top and bottom both by 2. 2 times 1. Okay, and that lets me write it just a little bit, well, I don't know that it's more compactly, but in a way that I can generalize here in a minute. So the 5p3 turned out to be 5 factorial over 2 factorial. Now I could do the same thing for any two numbers n and r. Just generalize. See, I had 5 factorial on top. 5 could be any number, n. So I'll have n factorial on top. And how did I get the 2? Well, that was 5 minus 3. You see, I put the 2 on the bottom in order to cancel out the 2 on the top. And what's the 2 on the top? I started from 5, and I took away 3 spaces, and there were 2 of them left. So the 2 was 5 minus 3. So I get n factorial over n minus r factorial. Okay, but in a previous talk, we learned that there's a relationship between nPr and nCr. So, I'm going to write down what we learned. We learned that for each combination, there are many ways to arrange it in different orders. For each combination of size r, there's r factorial different ways to arrange the members. So for every one combination, there are r factorial different permutations. So the number of permutations is r factorial times the number of combinations. That's from the previous lecture. There was some illustration, but just to remind you. So now that we have a formula for nPr, we also would get for free the formula for nCr. I just substituted my nPr from the permutation formula. And now to multiply fractions, I do the top times the top and the bottom times the bottom. And so there's my combination formula. Okay, well, that's what we were after. And now you can just plug in the numbers when you need to and work out lots of different word problems. And as we go forward in the course, that'll be the next challenge. Well, we've already done a little work with recognizing which kind of story goes with which kind of thing, and you combine that with these formulas and you can get numbers for your answers. I only have one more thing to show you in this video. I'm just going to show you the Excel functions that can do this arithmetic for you in case your class is using Excel. I'm going to use these videos for both a statistics class and a liberal arts math class. And so the statistics class has been using Excel, but liberal arts class has not, and in future semesters, who knows. But I'll just briefly show you the Excel functions. So if I wanted to do 5p3, just making a text notation here so I can see, we'll remember which one that is. So when we did it by hand just a second ago, 5 times 4 times 3, we got 60. Let's see if Excel can do that for us. To make a formula, I start with equals. And I'm going to start to type permutations. And it's this one, it's this permute. I'll click on permute. 5, 3. Close my parentheses. Say enter. And it says 60. So that's how you do the permutations. There were some other functions on the list there that dropped down that popped up. Well, those are for other things. We'll talk about those later. Okay. It's permute, not permutation A or anything else. Names look very similar. Okay. Next one is combinations. I wanted to do 5C3. Now, how many is that going to be? There's more permutations than combinations, right? For each combination, there are 3 factorial, 6 different permutations of size 3. So if I take that 60 and divide it by 6, I should get 10. So 5C3 ought to be 10. And it's this combin, not combine, combin. And I want 5. So how many ways can I choose 3 items from a set of 5 if I don't care about the order? Sometimes this is pronounced the 5C3. Sometimes people pronounce that. They say 5 choose 3. We don't really have a similar pronunciation for 5p3, but I would be tempted to say something like 5 permute 3. But I haven't heard that one very much. So I say, I'll click enter and it should say 10, and it does. Okay, so that's all for this video.